Now, I totally believe that all we need to do is see about 1,000,000 of these questions, and then it'll kind of solidify in our heads. We also need to keep on practicing them. So what I'm going to do with this example is I'm just going to talk you through how I would think about the problem, and not kind of give any more sort of mathematical explanations, kind of like what I did in the beginning intro video. This is just going to be simply going through an example. So A is 7 over x squared minus 49 plus 3 over x squared plus 14x plus 49. What I need to do is I need to factor everything I can. The numerator is already factored, so we're going to the denominator. This is a difference of squares, so we're left with 7 on the top, x plus 7, x minus 7, plus 3. The way that I would factor this one, it's x plus 7 squared. It's a perfect squared trinomial. 7 squared is 49. 2 times 7 is 14. At this point, we're going to consider our lowest common denominator, and it will be, so I'm taking care of one of the x plus 7s, so we're left with 1x plus 7 here, so we're going to say x plus 7. But in this one, so I'm going to check mark here, but in this one we have another x plus 7. So I need to write, because it's squared, so we're going to say x plus 7. The only thing that we have not taken in account for so far is x minus 7, x minus 7. Done. So what I need to do is I need, non-permissible values. X cannot equal plus or minus 7, because if I would put negative 7 here or plus 7 here, it would bring the lowest common denominator to 0, and we have something that's undefined. So I need to multiply by what I'm lacking here. I have an x plus 7 and an x minus 7. I need to multiply it by x plus 7 over x plus 7. So 7 over x plus 7, x minus 7, close bracket, times what we have left, x plus 7 over x plus 7. And this one right here, we say plus 3 over x plus 7 squared. So I have an x plus 7 times an x plus 7, so what do I have left? X minus 7. So I need to multiply by x minus 7 under x minus 7. We're looking at our denominators here, and they're both going to be the lowest common denominator. They match up. So I can just put them all under one common denominator, since these two are the exact same, because x plus 7 times x plus 7 is just x plus 7 squared times x minus 7. And I know some people are going to be like, is this the form you like better? Yeah, as simple as possible, because the question says simplify. So we go 7 times x is 7x. 7 times 7 is positive 49. We're finished with these two terms. Now 3 times x is plus 3x. 3 times negative 7 is negative 21. What I'm going to do now is collect like terms. 7 plus 3x is 10x. 49 minus 21 is positive 28, all over x plus 7 squared x plus 7 squared times x minus 7. Now, at this point, maybe we could factor something out, but there's nothing we can really factor out of the top that's going to be helpful, so that's fine. I mean, I could say 2 times 5x plus 14, but that's not going to help anything down here, so we can just let it be. I made a mistake here. Can we just add an 8 at 1 like that? Thank you! I was looking to see how I could factor it when it was just 8, and it's not possible with whole numbers, or sorry, with integers. So when we do this, two numbers that multiply out to 18 and negative 18 and add up to 3, we have x plus, I want to use n, right? N plus 6, n minus 3, minus, and do you know what? What the heck? Why don't we just put brackets around these guys already, just to show that they're factors. Two numbers that multiply out to negative 20 but add up to 1n. We have n plus 5, n minus 4. Alright, so we're all pretty factored. So why don't we find out what our lowest common denominator is? Well, it's going to be n plus 6 and n minus 3 and n plus 5 and n minus 4. There's nothing that's common between these two, so we literally have to multiply them all together. So we can state our non-permissible values right away. So n cannot equal negative 6, negative 5, 3, and 4. You'll notice that I'm going from least to greatest. That'll look good if you do that on your provincial exam next year. So now what I need to do is I need to consider what I need to multiply here by. So x plus 6 times x minus 3. What I need to multiply this by is n plus 5 times n minus 4 over n plus 5 times n minus 4. So we have the original n minus 3 over n plus 6, n minus 3 times what's left over in the denominator, n plus 5 times n minus 4 all over n plus 5 times n minus 4. We're noticing that we have this common denominator already, so that's really good. We have a subtraction sign here, minus n minus 2. Now we have n minus 5 and n plus 5 times n minus 4. So we need to multiply this one by n plus 6 times n minus 3 over n plus 6 times n minus 3. So n plus 5, n minus 4. So we multiply it by n plus 6 times n minus 3 all over n plus 6 times n minus 3. We notice that these two denominators are going to be the same thing. This matches with this, this matches with this, this matches with this, and this matches with this. So it's the exact same thing, so we can just like put them all over top of 1. N plus 6, n minus 3, n plus 5, n minus 4. So what do we have here? I'm going to keep them all in their factored little bits so we can see if we can cancel anything out. N minus 3 times n plus 5, n minus 4, minus n minus 2, n plus 6 times n minus 3. Alright, we're noticing that in all three terms we have this n minus 3. So what I want to do actually is cancel it right now. This cancels with this and cancels with this. And I know what some of you are going to say. You're going to say, like, Mrs. Woodyard, I thought that since there were pluses and minuses we couldn't do that. But if you can cancel out an n minus 3 or whatever variable from every single term, here's a term, here's a term, here's a term, if you can do that, that's good. We can't cancel n plus 5 in the same way, right? Because we have n plus 5 in this one, n plus 5 in this one. There's no n plus 5 in this one. Okay, the term after the subtraction sign. So we can't do that. So what I'm going to do is I'm just going to rewrite it. And I'm going to have to erase this side, folks, and then keep on going on this side. So we have n plus 5 times n minus 4 minus n minus 2 times n plus 6 all over n plus 6 times n plus 5 times n minus 4. So that's what we have left over. Moving right up here, continuing with our problem here. The way that I can simplify that is 4 n plus 5 times n minus 4, n squared plus n minus 20 minus, and since it's a minus sign, I want to put a bracket around it, just so that we can make sure that we don't forget to lose or to forget to distribute that negative throughout. N squared, they add up to 4 plus 4n, 12, it's going to be negative 12, negative 2 times 6, minus 12, all over the common denominator of n plus 6, n plus 5, n minus 4. So I'm going to distribute that negative to all three terms. N squared plus n minus 20 minus n squared minus 4n plus 12 all over n minus 6, n plus 6, n plus 5, and n minus 4. N squared minus n squared is 0n squared, so that's good. N minus 4n is negative 3n. Negative 20 plus 12 is negative 8 all over n plus 6, n plus 5, and n minus 4. Holy Hannah Montana. That, my friends, is a very long question. And I wanted to make sure that I went through at least one long question with you. I know your hands probably hurt by now, blah, 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 blah. But I wanted to make sure that I had done one of these really long questions for you, just because, yeah, they are pretty tough.